This is the Physical Activity Researcher Podcast, a podcast for researchers of sedentary behavior, physical activity, and sports. Join for a relaxed dialogue about research design, practicalities, and, well, anything related to research. Learn from your fellow researchers useful and relevant information that does not fit into formal content and limited space of scientific publications. And here is your host, researcher and entrepreneur Olli Tikkanen.
Welcome for Physical Activity Research Podcast, and today we have a guest, Eero Haapala from the Faculty of Sport and Health Sciences from University of Jyväskylä. Welcome.
Thank you, and thanks for the invitation.
Yeah, my pleasure. So, what are your research interests?
My main research interests, they concern children, adolescents, and their brain health, and more recently, vascular function and structure.
All right, so quite different, the vascular things and the brain things. So are they?
In the first place, they seem to be quite distant, but I think they are quite closely related if you look more closely. Like you have to have some kind of blood flow to your brain, and it's somehow related to your vascular function and vascular health.
Yeah.
I think that's the one reason I ended up to research both of these different topics.
All right. And how long you been studying the arteries and blood flow now?
I think it's something 3 or 4 years.
All right. I think we haven't met in a while because last time I saw you, it was more about the brain and cognition. So yeah.
But as a more regular base, now it's 1 year or 2.
Yeah.
But started 4 years ago, I think.
Yeah, and you started your research with the cognition studies, or how was your PhD and the first studies you did?
Yeah, I started with academic performance, mostly reading and math skills, and then moved to more cognition, reasoning skills, and more abstract things.
Yeah.
Functions not directly related to learning, or they are related to learning, but not that we can measure like reading or calculating.
Yeah. So if we start from the basics, I don't know much about cognition. So why is there a link that if I move my legs sometimes, which is physical activity, it affects my brain function? Why is that, and how is that?
Well, we can start really from the past, or just the basic mechanism.
We can start from the past, maybe. That's an interesting start. Yeah.
From 10,000 years ago, the hunter-gatherer populations, of course, there's a need for physical activity. You had to collect your food, hunt, and after your hunting, you had to find your way back home, and you had to have really nice cognitive skills to find back home, but also for hunting and finding food. So there's that kind of evolutionary link that physical activity and cognitive and brain development are related.
All right.
And then you know that physical activity levels has declined quite a lot these days.
Yeah.
Now it's possible to sit all day and have just only really low amount of movement.
Yeah. I think I have read that while you're eating, your memory works better because it's been in evolution. It's been beneficial to remember how did you actually catch the animal or found the food. So, and then you said about physical activity that you went to do something and to find back home. Is this like just an idea, or is there some proof of this link between physical activity and remember it back to, or have you read, is there any, how do they came up with this?
I think we don't have that direct evidence, of course.
Yeah.
I'm not that old.
Yeah.
But this is not really strong support, but when ancient populations started to travel around the globe, also the brain size increased. That has been confirmed in anthropologist studies.
Yeah.
It's not a direct evidence that the physical activity was the key, but they are linked. That once you started to travel, also your brain started to grow.
All right. So now we kind of made the basic that why is it linked, and then how is it linked? I don't know much. Like how is it messaged to the brain, and how does this work? What do we know about these things?
Well, why and how? It's always when you move, something happens in your brain. Of course, because the brain is controlling movements.
Yeah.
That's the first link. But it's not the only link, because that's only the neural link.
Yeah.
But every time you start to move at a certain intensity, more intense exercise, of course, produce more physiological adaptations and responses. But there's an increase in several neural, growth factors. So the exercise induce increase in that kind of brain health enhancing factors. That is not directly related to brain, but it's more overall response to exercise.
So you have the neural response, and then you have, how would you call it, hormonic response, or
some kind of endocrinological response. So that's a brain-derived neurotrophic factor. I think it's the most researched factor.
Yeah.
And it has been related to increasing newborn cells and their survival.
Yeah. And is it known? Is it kind of response in the motor to the motor activity in the brain, or is the muscle actually needed there, or does the loop go all the way to the muscle? How?
I think that the muscles are needed, so the brain function itself is not enough. You need that kind of metabolic action as well.
Yeah, that's very interesting. And is there there's usually this kind of sensitive periods for children to develop flexibility and other capabilities? Is there research findings showing difference between adults and children in this regard of the beneficial effect of physical activity for brain function?
Yes, there's in fact quite nice evidence that young children, pre-pubertal children, they are more responsive to exercise than adolescents or young adults. But then again, the older adults, the exercise has quite large effects on cognition and brain function and brain structure.
All right.
Probably because children, their brains are developing, and on the other hand, in older adults, the brain functions and brain health is declining. So there's a developing and declining. These are the periods when you need some exercise and physical activity.
Yeah, very, very interesting. And you've been also studying the dietary factors. How does this diet come to play into this?
It's always interesting because I'm an exercise scientist and studying just nutrition. And in our studies, it has been surprising that nutrition has more effect than physical activity actually in children. But our population has been quite physically active, so perhaps there's more to improve in nutrition. But basically, why nutrition is needed, your nervous system needs building blocks, something that they are built on, like fatty acids, proteins, carbohydrates, all are needed. And we have found that this is actually quite lame. I'm not supporting any really nice diet that you should follow, but just basic nutritional recommendations, high fiber, vegetables, fruit and berries, fish, and that kind of diet has been related to better cognition in children, adolescents, older adults. Really basic things.
Yeah, so I can see the link from the fruits and the vitamins brain health, but how does do you have any guess why is the fiber important, or high fiber food?
Yeah, it may be related to gut function. The gut microbiome may be something to do with it, because there's a connection between your gut and brain. It's quite novel area of research, and I think we are not yet there that we can definitely say that what's happening.
Yeah, it's actually really interesting, the gut microbiome, and how it seems to affect so many things of our functioning, but it's sometimes really confusing to understand the links that why are these things linked together. So dietary fiber is linked to gut microbiome. Yeah, that makes sense. So was there any other the fruits, fibers, and what was the third?
Fish, probably because of fatty acids.
Yeah.
DHA and EPA.
Yeah.
Acids, they are, well, neurons, they need them.
Yeah.
And they form.
So, and you did this study with the Finnish children?
Yes.
Yeah. And was how big were the effects with the effects of diet to brain function in your studies? Cognition, yeah.
We haven't measured all the reported brain function yet, but effects, I can say that they were meaningful, but of course really large, because always when children are growing and getting older, also their cognitive functions are getting better, although they are not doing anything special.
And do you think it was more about that some really have deficiencies in, for example, in fatty acids, or did it seem that they didn't have deficiencies, but it seemed that you get more, you have better cognition, or what do you think?
Well, in our children, they didn't really have any deficiencies, but their nutrition quality was not optimal.
Yeah.
They quite often get too much saturated fatty acids, too much sugar, and the basic things that are quite often a problem in the population level. But we have shown that those factors really improved in our intervention, and probably that has some benefits to cognition as well.
Yeah.
Or at least it seems to be like that.
Yeah, and once again, the basic dietary recommendations seem to even for cognition seems
so
to
boring,
be
true.
It should have been that eat McDonald's and your brain will be doing better. There are other things maybe not, but still went the same way. Yeah, and you've been also you state in your research interest fitness and fatness. So what do you have to say about this? Yeah.
Well, that's always something that I probably get some feedback. You can't say that. But like I said before we started, I think we have done most of our research wrong. We have used measures of fitness that are not really measures of fitness, but combined measures of functional capacity and body fat content, like dividing peak VO2 by body mass. It's not really a good measure. And I was just writing a paper showing that if we really do our controlling of body size well, it's not related to insulin resistance. And that physical activity is more important than fitness. And that's something that has been argued that it can be that way, that fitness is more important than physical activity.
So what do you think is a good measure of fitness then? How should fitness be defined or measured?
Well, I mean, we can measure it many ways. In that paper I was writing, we had a maximal cycle ergometer test, and we didn't collect respiratory gases, so we had just maximal power output. But we controlled it for body size using a lean mass, which is physiologically most appropriate because your muscles are making movement, they are metabolic active during the movement. And they also increase your venous return, so that's effect on your stroke volume, and it is the most important factor in your fitness. And we also did some allometric modeling that we really took account the body size. So we can really now compare individuals with different sizes.
And you said that physical activity is more important than fitness. Why is that?
Well, because the measure of fitness we used, it is not now related to body fat content. And we know that increase in body fatness is related to insulin resistance. And if we have a measure of fitness that is not related to body fat, there should not be that much confounding. So fitness, as a measure we use it, it's not really insulin resistant. And why physical activity is related, or is more strongly related, I think there's a quite nice physiological rationale for that. Because of course, when you are moving, your muscles need more glucose, and the glucose disposal is increasing, and with increasing intensity, also the novel mechanisms.
Okay, let's get back to that in a moment and hear a few words from our sponsors.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Furthermore, Fibion has been shown to be valid categorizing physical activity into light, moderate and vigorous intensity. Get scientific validation and learn more about Fibion at fibion.com/research. The Physical Activity Researcher podcast has created an activity tracker purchase guide for researchers. Get your free copy from the link in the podcast description.
So is fatness the most important thing for the insulin resistance? Was that what you said? Or?
Unfortunately, that's the case, at least in children.
Yeah.
It is possible that when you get older, fitness has some role. In that young age, it seems not that important.
And is it independent of fitness? Like if you actually, let's say you're a sumo wrestler, you're really fit, but you have high fat content, do you think it would still be the same, or how would it go?
I think it's the same. If you control fitness for the body size appropriately, I think that fitness has not that big role.
All right.
But if you are a sumo wrestler and you are physically active, I think that makes the difference. I think we can compare a sumo wrestler who's quite huge, and then there's the couch potato who can be really lazy and sedentary and still quite huge. I think there's differences in insulin resistance because the another one is active.
And then we moved from the brain cognition, I see, to insulin resistance. Is this what you are doing at the moment mainly, or what's your main research thing at the moment?
My main, that's how. I just submitted one paper on physical activity and academic performance. Now I'm working with insulin resistance, but also with some physical activity measurements. Things. So I think I can just concentrate on one thing and always doing something else and trying to find something interesting. And we also have some fatty liver markers going on.
But these all are from the same data set, or?
Well, the health outcomes are from the same data set, but here at the Faculty of Sport and Health Sciences we have done a physical activity measurement study. We're trying to define what is sedentary behavior in children. How can we define physical activity intensity in children? Because that's one thing we are not really. We don't know much about that.
So what do you plan to do with the physical activity assessment with children? Do you plan to develop some new methods, or what's your plan?
Well, not new methods maybe. I think it's more your business.
maybe.
But maybe some theoretical or practical things how we can define different physical activity intensities and improve the accuracy in a population level when you try to assess, for example, vigorous physical activity.
Yeah.
It's really hard in the methods we are using now.
Yeah. Why is that?
Well, the basic problem in the known calibration studies that they have decided before that sedentary and that moderate and that's vigorous activity. But they haven't really defined that why it is.
Yeah.
It just that feels that it is, but that's not true. And we have the metabolic changes. We have measured respiratory gases. We have EMG, heart rate, and accelerometers. So we basically know what's happening in the body in different exercise intensities.
Yeah.
What we have done, for example, now we have anchored the vigorous intensity to ventilatory threshold. So there's change in metabolic profile to a certain point, and that's something that no one has done before.
Yeah, it is quite simple division, like divides just light, moderate, and vigorous, and it's from the energy expenditure perspective, which is only one perspective of defining activity. I was just talking with Timo Rantalainen, and we were talking about defining those same things with the elderly. And with the elderly, it might be that their maximum is lower than the threshold of vigorous activity. So basically, some individuals can never reach the vigorous intensity activity.
Yeah, that's right.
So then they have only two categories of light and moderate. And so Timo was using that he's dividing it like to much smaller categories, kind of histogram view of it. And I think that could probably be useful. We have data that is continuous, and then we divide it just to few blocks. Of course, it's easier to report, but maybe reporting the whole histogram or whole continuum would be useful. So you said muscle activity, ventilatory thresholds. Are you measuring these in your projects?
Yeah, we have a lab project where we measured almost everything you can measure in children.
Yeah.
Ethically.
Yeah.
We measure much more.
Yeah.
We have really nice data. We have collected that already. So now we're in a reporting phase.
Yeah.
Trying to find out what to do with the data.
Yeah. Yeah. I'm thinking like usually children they take quite short sprints. So it might be like neuromuscularly quite demanding, quite intense. But if you do it just for 5 seconds, it's probably not metabolically very demanding. You don't have enough time to actually get the heart rate and respiration going. Have you looked at these at all?
Not actually, because the real life validity of all that kind of calibration studies is a bit limited because we often use 4-minute, 5-minute periods we measure as long as they reach the steady state.
Yeah.
And like you said, the children quite often move really fast and then they rest.
Yeah.
And we can really measure that kind of periods.
Yeah. And if we go a little bit back to the cognition, have you found that certain type of activity is more beneficial, or is it the same for light or moderate or vigorous activity?
Now we go to the whole physical activity spectrum. There's a different type, and then we have intensities.
Yeah.
Well, the types, it's probably that in children, if you include some kind of motor challenge, balancing or playing ball games, it's more effective than just walking around or running around the track.
Yeah.
But there's a research that has shown that also the running and walking is effective. But the exercises are probably larger. They are more interesting and
so actually like, do I understand correctly that if you're doing physical activity that is challenging your motor system,
and brain as well.
You will be better in maths, for example.
The effects are larger, a bit larger.
All right, yeah, that's interesting. Yeah, so there's kind of cross function in a way.
But there's also some data showing that if you have a really demanding physical activities, they may decrease your performance shortly afterwards. But that's not the most common finding.
Yeah. And how long do you think this will last? This decreased performance, like, has anyone measured it?
I think there's not good data showing how long it really lasts. Probably not too long.
Yeah.
Maybe a few minutes.
Yeah.
10 minutes. And I think that must be really demanding.
Yeah. A really demanding motor task that kind of takes away something. Yeah. And do you think this is same for the elderly people?
It's quite the same.
Yeah.
Most often they have studied just aerobic exercise, and it has proven to be quite effective. Also for the brain structure, but at least one study has published also really simple motor activities without any metabolic demand, and it has almost the same effects as aerobic exercise.
Yeah, and actually, if you think like the physical activity of quite a large chunk of adult populations, it's usually just walking, which is quite not very demanding from a motor perspective. So should the recommendations be a little bit different, that it would be more skillful things that we encourage people to do?
Yeah, I think we can even emphasize more balance skills, and especially for children, not only giving the amount of moderate to vigorous physical activity, but really showing that motor skills, but also muscle strength might be important. In cognitive aspects. Point of view. So I think we can emphasize motor skills and motor learning more in elderly and in children. And why not in middle-aged adults as well? Because the decrease in motor skills probably starts quite early. And not having that kind of exercise. This
goes a little bit in the different end of the continuum, but I personally have sometimes felt that if I do, for example, really hard, high intensity interval training, that my cognitive function has declined for maybe 2 hours. Then I go to a restaurant and I try to order like which pizza I want, and I cannot make the decision. It's really difficult. I don't know. Maybe it's the lack of oxygen in the brain after the high intensity.
There's evidence really that if you have a really high intensity, your blood flow to brain decreases or plateaus. With some individuals, not maybe all. But there's also evidence that the high intensity training has the largest effects, but not immediately, but sometimes after the exercise.
So it is kind of super compensation that your brain function goes bad for a moment and then it goes.
But the most safe way is just to have a moderate intensity physical activity, because it has it's mostly beneficial and the negative effects are quite small.
No, very interesting. I had some idea in my mind, but I think we lost it forever. And your other studies now, what you've been doing some years is about arteries. What's interesting with arteries?
What's interesting? I think everything is interesting with arteries. But basically, still the heart diseases are the most common cause of mortality and morbidity in adults. And heart diseases have their origin in childhood, so I think it's quite important to find out how we can prevent that kind of population burden since childhood.
And there's many people probably think arteries just as a way to transport the blood. What are the adaptations in arteries related to physical activity, diet and so on? What's important to measure from the arteries?
Well, of course, the function, how well they can change related to demand. If your muscles need more blood, they have to delay it, so the more blood can be transported to exercising muscles. And also, it's the same with the brain. If your brain functions are increased, brain activity increased, your brain needs more oxygen, more nutrients, that you need to dilate your arteries that you can transport really oxygen and nutrients.
Yeah, now I remember the thought that I lost. It was about the blood flow and sedentary behavior in the brain. There was some studies showing now that after 6 hours of sitting, you start to get reduced blood flow in the brain. And I think it's quite interesting that why is there a link between sedentary behavior and blood flow? And do you think it's the same? Is it in the same continuum that the physical activity improves brain function?
Yeah, I can see it that way.
Yeah.
But it was really 6 hours of sitting reduced the cerebral blood flow, and physical activity prevented that decline in adults. And actually, I think they didn't have 6 hours of sitting in children, more 4 hours, and in children that kind of effect was not found.
All right.
Probably because they are more adapted to keep their brain function going on, and adults probably have more time to just ruin their arteries and function is not working at all.
Yeah, that's very interesting. So let's hear a few words from our sponsors and get back to that right after.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Get scientific validation and learn more about Fibion at fibion.com/research.
So what kind of projects do you have upcoming about arteries here in Jyväskylä?
Well, we have now menopausal women. We are measuring their fitness and arterial stiffness. And later, we have devices we can measure microvascular function and endothelial function more accurately.
Yeah.
So we are trying to find out which is more important for vascular health, this fitness or physical activity, sedentary time, or maybe nutrition or body composition.
Yeah.
And then we try to figure out if increasing physical activity can even more improve the vascular functions.
Yeah. How long there's been this increased interest for the vascular function? Like, because everybody knows about athlete's heart, and the heart gets bigger and stronger when you do exercise, and if you're an athlete, but the talk about veins and arteries, there hasn't been much. Like when I was studying, for example, I don't even remember any book mentioning about it. So how long there's been research on this?
I think the research has been there for decades, but I think it has been increased a lot within the last 10 years.
Yeah.
And now there's some recommendations from, I think, American Heart Associations.
Yeah.
Association that arterial stiffness measurement can be applied to a daily practice medical setting.
All right.
Just to increase the predictive power of future cardiovascular events.
All right, that's interesting. And do you think this increased interest is because better research methods, or just somebody started paying attention to it?
I think it's because of both.
Yeah.
We have now quite nice, easy, non-invasive methods to measure arterial stiffness and endothelial function. And of course, we have more research showing that arterial health, function and structure are independent factors that predict future cardiovascular events and mortality.
Yeah. So you said that there's better methods to measure arterial stiffness. Do you want to give like a short introduction? How is it done?
How it's done? Well, I think the most easy method we are using here, it's like a blood pressure monitor.
Yeah.
It's the cuff on your upper arm, and
Yeah.
it works really the same way.
Yeah.
In the blood pressure monitor, but the algorithm is a bit different, and it calculates the pulse wave when your heart ejects the blood, and then the reflecting wave that comes from the bifurcation of your heart. So the basic function is really easy, just tie the cuff on your patient's upper arm and then press the button start.
All right.
And just check that the data was good.
Yeah.
I think that's the most easy way you can do it.
And what price range is this kind of device? I think like when will it be like home use device?
Well, the most devices are less than 10,000 euros.
Yeah.
So in the clinical use, I think that's not really that much.
Yeah.
And the device we have, it was something like 4,000 to 5,000 euros.
All right. Yeah.
So not for the home use yet, maybe.
Yeah. But could be maybe in the future.
Yeah.
Many things get quite much cheaper with the improvement in technology. So that was how to measure arterial stiffness, and you mentioned some other variable to be measured. Yeah.
I had to measure endothelial function.
Yeah.
That's a totally different way, of course. You had to somehow stress your endothelium, and it's commonly used using closing the artery of your upper arm and then looking at how much it's delayed after you return the blood flow.
So basically, the blood is rushing to your arteries.
There's a hypoxia.
Yeah.
And so you need to close. You again have a cuff.
Yeah.
You use to close the artery, and then you have different. Either you can use ultrasound to measure the dilatation.
Yeah.
Or then you have a different laser Doppler.
Yeah.
For example, can be used to measure the blood flow.
Yeah, and which way does it go? More it delays, it's better,
It's
or
better.
vice versa? Yeah, so you need to have quite a bit of dilation there. Yeah, that's interesting. Yeah, any other things you would like to discuss?
Wow. At least, of course, the mechanisms how physical activity affects on brain. That's again one line we can continue.
Yeah, that's interesting. Yeah.
I think most people are interested in why and how and its direct effect on. Because here in Jyväskylä, also done some evidence that sleep is important and some other things are also important. So we can continue at different levels.
Yeah.
So why? Because we know that physical activity may improve your brain structure, like the hippocampus, the memory center of your brain. There's some evidence that with physical activity, the size of the hippocampus increases.
Yeah.
And also it's related to improved memory functions.
Yeah.
That's important. That although you have increased size, it may not always relate to increased performance.
Yeah.
But in that case, it is.
Yeah. And how much is it like? Are the memory performance and then other cognitive tests, how well they are linked? That if your memory function improves, are usually the math scores better, or how is the interplay?
But there's some intercorrelations. So if you have executive functions inhibition, so you can efficiently concentrate on tasks on hand. So you need some working memory and perhaps some long-term memory, so you can efficiently handle the task. So they are related. Partly separated.
Yeah.
But still there's some link between them.
Yeah.
And especially if you have that kind of exercise that includes some kind of cognitive aspect.
Yeah.
It probably has the effect on the cognitive aspect you are practicing. if you have to memorize something during your activity, it probably has larger effects on your memory and not just concentration.
Yeah. So it's kind of memory practice, actually, the physical activity at the same time. I'm thinking like I was playing baseball for 20 years when I was younger, and there's quite a lot of thinking involved in the game. You kind of, especially in some positions, you are thinking like what is the opponent thinking, what is the coach thinking, and then what they are thinking of that I'm thinking that I will do, and then it's quite complex things you're going in your mind. So I think it was good that I played baseball. No, very very interesting. Also in this podcast we try to kind of share tips and things that usually doesn't get mentioned in the scientific publications, but you have learned important and relevant things, whether it's about how to do measurement, how to apply funding or something. Would you have anything to share that you have learned in your research career?
Well, not very related to funding. Not being that efficient in that regard. But perhaps with measurement in children and in research in general, you have to be quite kind and friendly. Because otherwise your working atmosphere with your colleagues and with the children won't work really well.
So how do you usually manage, for example, if you're doing physical activity assessments, how do you get the children to wear the devices, not to lose them, not to break them? Is there any tricks to do that?
Yeah, I usually said that if you break it, we just pay it. Because they always cannot play football with that then. But if I go to karate or judo, well, if it gets broken, that's our bad. Don't worry about it. So children are really interested. What happens if I lost it or if I broke it? So I think it's the problem. And that's why they have sometimes forgot to put it on, but they have been afraid. It's a problem, but it's just take it easy. It's not your fault. It gets broken.
I also read that the coherence was better when you add a Superman sticker to your accelerometer.
Some kind of super device. And the wrist run accelerometer. Oh, you had that kind of super watch. That's great.
And one of my colleagues was saying that he usually takes like 3 to 4 children at the same time when he's explaining like what they are doing and when he's giving the devices, because then he gets like, it's a small group enough that they kind of feel that they need to behave, but then they are not alone, that they don't get too nervous. So he was finding that 3 to 4 is the perfect amount for that. And how do you do the cognitive tests? How they are best performed?
We have had individual tests using either computers or paper and pencil tests. And well, it's sometimes really hard. I have used a computer-based test for adolescents. It's of course quite easy. Just tell what to do and they do it. But the younger children, it's more introduction, everything, and you have to do that and that. So you just have to be patient. And one practical and personal experience about attaching active pals on the thigh with that tape. Well, attaching is okay, but taking it off, you have to really be gentle.
You're the bad person then.
Maybe use some water. And telling that it may hurt a little bit, not too much. You get a sticker afterwards. Or something.
And are you using the Tegaderm or which?
Or corresponding.
So it sticks quite well.
And sometimes in our school measurements, we have just cut it out from under the tegaderm film.
Yeah.
And they have took it away back home.
Yeah.
When they can go to shower or bath. So it gets a little bit easier. So we have to cut it the whole.
Yeah, so you take just the device off and leave the tape. That the adults need to be the bad person to pull it off. Yeah. How well the device has usually stayed with children when you tape it on the thigh? Have you had problems it staying for 7 days, or how well it works?
I think I only had problems with 1 or 2 children.
Yeah.
They more often like to have it for a long time.
Yeah.
And take it away.
All right.
Because I think they realize that it's really tight attached.
Yeah.
And so we can't just give them. Thanks.
Yeah. So that's when you started just taking the device off and leaving the tape on.
Of course, some children feel some aching or it's getting a little bit annoying. Of course, when you're sweating, stitching.
Yeah. And do you feel that it's better actually that it's on the thigh and the children don't see it? It's just kind of there and they can forget it, than if it's on the wrist that they kind of all the time notice wearing something.
I mean, they forgot it if it's in the thigh or wrist or anywhere.
Yeah.
It takes that 1 day or with some children 1 hour to forget it.
Yeah.
We have used the hip burn and then the thigh burn.
Yeah.
And I trust more the thigh burn.
Yeah.
Because quite often children forgot to put the hip burn device on. And they take it off during night or during shower.
Yeah. It stays for a longer time. So usually you use the thigh worn device in your studies. Yeah. All right. I think it's been really interesting discussions and actually a lot of new things for me, as I didn't know too much about cognition and the link with physical activity. So thank you for being a guest in this podcast.
Thank you.
This podcast is sponsored by Fibion. Get scientific validation and learn more about Fibion at fibion.com/research. The Physical Activity Researcher podcast has created an activity tracker purchase guide for researchers. Get your free copy from the link in the podcast description.
Thank you for listening to the Physical Activity Researcher podcast.